ማለት ስለዚህ in rocket propulsion we have various method of classifying rockets so that these are some of the classification method that we can classify the rocket and its propulsion system. So energy sources, type of vehicles, the basic function of the rocket, whether it is booster or sustainer, by the size of the rocket, by the number of rocket propulsion units, and by the method of producing thrust for rockets. So based on this, we classify rockets into different categories. And this is the basic constructional feature of full rocket, what it seems like. Okay, so where is our pilot? It is a very small part of the whole rocket, that is pilot. The remaining maximum part of the rocket is full of just the fuels. Okay, it is full of the fuels and other combustion mechanisms. So that is what we have discussed last time. The working principle of rocket motor, how rocket motor works, what it is resemble with the jet engines before, what we have discussed. So these are what we have discussed in the last lecture, and how we can get a thrust from a given rocket. So by the action and reaction principle of Newton's third law, we can get the forward motion of the rocket. And we have tried to see the rocket equation, fundamental rocket equations, and the thrust equation. Okay, so what are the components of thrust equations? This will be the next discussion in another time. So these are what we have discussed last time, and the classification of rocket propulsion itself, just chemical propulsion and electric propulsion, other like that. Then we summarize 3 Newton laws. So that is basic physics of which everybody knows. I can consider you are familiar with that. And the propulsion system types, okay, cold gas system, monopropellant system, bipropellant system, solid propellant. This is based on the propellant which we are using. So some of them are cryogenic propellants, some of them are hypergolic propellants. What are they? This is what we have discussed last time. The monopropeller, the cold gas system is the simplest form of propellant propulsion system in which we use when it is compared with others. And how the gaseous propellants comes out through the nozzle and produce very expanding gas through the nozzle, how it comes out. And so these are what we have discussed last time. Advantage and disadvantage of cold gas system, monopropellant system. What monopropellant? Just using a simple hydrazine and decomposing the hydrazine propellant, the propulsion will take place. But it is with less thrust and less specific impulse. That is the disadvantage of monopropellant system. So that is what. And bipropellant system, which consists of 2 gas, liquid gas like oxygen and liquid oxygen and liquid hydrogen. Okay, so that is the system consists of 2, and it needs 2 complex design of oxidizer tank and the fuel tank. Pumps also are required. At the same time, if we are using some turbo mechanism, then shafts are also required. So kind of complex design than the previous. Okay. And then another one is solid motor system. So in our solid motor system, our propellant is a solid one, which is cast in predefined or pre-designed shape. There are various shapes of propellants which are made in casting to the required shape based on our intended propulsion system, or based on the ignition which we need. Okay, so propellants are casted, and which sometimes we cast it inside the casing, okay, inside the motor itself, and sometimes we free cast and we mount it into the propellant casing. Okay, so that is what we have discussed. The comparison between these four propellant systems or four propulsion systems are here, based on its specific or the performance characteristics. Like energy is one of the performance characteristics, but ISP, specific impulse, thrust range, thrust bulk density, the density of the gas which we are. So these are the parameters we always look for. And chemical propulsion system, finally, we categorize chemical propulsion system into liquid and solid, and also hybrid. When liquid and solid come together, then it becomes hybrid. So this is the classification of chemical rocket system. And all the intention is to produce the thrust, to move the vehicle forward. Okay, so the intention of all propulsion system is to make our vehicle to move forward. So here we have all solid propellant. Here we have liquid oxygen, liquid hydrogen. Here we have liquid fuel, liquid oxidizer with solid fuel grains. So that is the combined or hybrid system. Now, I think we stopped on solid rocket motor. So we'll see this solid rocket motor in detail, because we'll take some assignment on this, because once we know this solid propellant rocket, we have some solid propellants. I know it is there in Ambo, so we can use those solid propellants, and we can make some model rocket. Even in your level, 3 of you, if you take individual component of the rocket, we can create one small rocket. Means that can perform some specific application. So we can make at least some rocket. For that purpose, I will give in the full intention on this. So once you understand these parts, you will just think what you can do. Okay, so for that purpose, solid rocket motor consists of casing that covers overall structural system. Okay, this is a solid rocket casing. And then after, you can see another small thin layer here with some yellow color, which is called insulation layer. So insulation must be selected in proper way, because high heat from combustion chamber is there. That should not come out to the casing. Means if it come out to the casing, it immediately collapse or damage the casing. So that casing must be protected from any kind of temperature which comes from the surface. So we need heat protective material or insulation material. And then when you come in, it is a solid propellant. This is a solid propellant which is manufactured for by different. There are some design aspects of solid propellant itself. So either it is casted and mounted to the combustion chamber, or it can be casted into the system itself. So there are two methods. Anyways, this is a solid propellant itself. Then we have igniter. Okay, this is a small igniter which initiates the propulsion system. Okay, so igniter is made from some fire-sensitive material. We have two categories of igniters. We call them as pyrotechnic igniters and pyrogen igniters are there. So what are pyrotechnic and what are pyrogen? We will see them. Anyways, this is an igniter and some igniter attachments are here. We must attach the igniter into some igniter casing. Also, igniter design alone is a big project. Okay, so this is solid propellant igniter. There is also a nozzle that allows us that convergent divergent shaped nozzle, so that is also fitted into the casing like this. And there are some casing fittings, means to attach the casing with the structure, there must be some fittings are required, but that will be some extra discussion. Anyways, so this is the nozzle. So mainly we have 5 major components here. 5 major components. Each components will be discussed thoroughly in our even the preceding discussions also. Okay, so so solid propellant motors, the ingredients to be burned are already stored within the combustion chamber or in the casing. Okay, so the burning the burning material is already stored into the combustion chamber inside the casing. Okay? The solid propellant, we call it as charge. Sometimes we say solid propellant, sometimes we say charge, sometimes we call it as grains. Okay, and it contains all chemical elements. So these chemical elements are both oxidizer is there and fuel is there. Okay? And it is expected to be burned in very smooth and predetermined rate. Means the burning should be predetermined. It has to be designed in proper method. We don't need any detonative type of burning. We don't need deflagration type of burning, but a smooth burning of propellant is required. Initial burning takes place at an internal surface. Look, initial burning of this propellant takes place at this surface, at the inner surface. Actually, when we ignite propellant from inside to outside, that is called progressive burning. And sometimes we may ignite it from outside to inside. Then it is called the opposite of that progressive. I forgot the technical word. So it is opposite to that. But most of the time, the progressive burning is expected. Why? Because we need to accelerate our vehicle more and more. So there are different shapes of different shapes of propellants that gives different type of burning rate. So burning rate is also one of the criteria that we can calculate. The internal cavity expands as the propellant is burned and consumed. Yeah, this is because high hot gas is produced in the inner surface of the combustion chamber, and that makes an expansion. Okay, that expanded gas are coming through the narrow section of the nozzle, and then accelerates out from the nozzle. So the resulting hot gas flows through supersonic nozzle. Actually, supersonic nozzle means at this region. Here it is supersonic region. Behind of the narrow section, it is subsonic region. Here it is subsonic. Because flow speed is very confined there. But when it comes to expanding nozzle, means that what we call diverging nozzle. Initially, it is converged towards to the throat. Okay, here is converging side of the nozzle. On that, the flow is highly subsonic because of high pressure. And then when it comes out from the narrow section of the nozzle, it starts to accelerate in very high speed so that it is supersonic. So it comes through the supersonic nozzle to impart thrust. That is the required thrust. So once ignited, the motor combustion is designed to produce an orderly manner until all the propellant has been consumed. One thing we must understand in solid propellant rocket, once the solid propellant is ignited, then it will not terminate. We cannot stop it. It will go continually till the end. So that is in safety aspect, or that restarting the engine is not possible. So that is the failure of this solid propellant rocket. So in solid rocket, now we are coming to the constructional feature. So the 5 important sections which we have discussed are the motor case, the insulating material, the igniter, and the propellant train itself, and the nozzle. Okay, so let me give number for this one. Okay, insulation, internal insulation as 2. Then after propellant grain 3, and igniter 4. Then nozzle 5. And there are some sections that thrust termination mechanisms, thrust vector control mechanisms. Some mechanisms are there. So so these are some of the constructional feature in 3D representation. So in this case, we have a casing which serves as propellant tank or a combustion chamber. So this casing must be designed for different aspects, like high stress that result from thermal stress that result from internal combustion. The external environment means it is exposed to external environment, so that there is a pressure from external environment, so that this material must be manufactured with proper material type. That should be a high strength steel is required. Most modern propellant shafts are, when we come to propellant shafts, which are formed by pouring the viscous mix into the motor case. Look, the propellants, the chemicals are molded or manufactured by pouring the viscous mixtures into the casing chamber. And the casing chamber, there are some mold cavities, or like some shaping things are there. So it will take the shape of that. With suitable mold fixtures, we need some fixtures also. Look, you know what are fixtures in mechanical engineering? Fixtures are tool holding device. Okay, if you are design students, you know what are fixtures, what are the jigs. So these are tool holding device, or the which supports the formation of the shape of the propellant grain inside. So the propellant solidifies using polymerization process, and then the mold fixtures are removed. The fixtures will be removed because that are extra matter, and leave the propellant bonded into the motor case with suitable shape perforation. Perforation means that, for example, there is a star type, there is some hollow structures we intentionally leave for advanced propulsion system. So all those perforations will be left. During operation, the solid propellant burns on the exposed inner surface. They burn away at predictable rate to the desired thrust. This predictable rate is called burn rate. We call it as R dot. R dot is equals to A times R is the power of N. We will see what this formula, what is A, what is R, what is N. So R dot is equals to, dot means burn rate. It is time rate. That's why burn rate. So A R the power of N is the burn rate. So with this predefined burn rate, the propellant will burn. Now the first part is rocket motor case. Motor case is the first part. That is generally consists of steel or aluminum tube. For simple construction, we use aluminum tube. For real rocket case, we use high strength steel, not simple steel. Okay, and which consists some head in this dome. There are some domes in the head, and it contains some parts for igniter. Means to put igniter casings. We have here igniter, and there are igniter casings. So igniter casings will be fit into the motor chamber. So for that, it allows this also. And after end, there is nozzle attachments. Look, there should be some nozzle attachments with the help of metallic structure. So it supports both these things. All these things are supported by motor case. So there are also insulations just beneath of the motor case. There is insulation, and the material for rocket motor case are high strength steel. This is directly using conventional material, steel material. And when we are using the modern technology material like composite material, then we use filament winding. So is there, let me ask you one question. Anybody knows about composite material?
Yeah, not much, but we've taken structure class and we've modeled it on, tried to model it on Abacus or something.
So what are composites? If you know some idea, what are composites?
I think it's a mixture of two or more materials with different physical and chemical properties.
Exactly. It is the mixture of two physically distinct, chemically distinct materials with different property. They combine together to form a material with better performance. Like, for example, if you use some carbon material with some epoxy together, you form, epoxy is very weak in property, like in the tensile strength. And carbon is weak in compressive strength, means when we compress carbon, it can easily break. So when these two things together come together and combined in some pre-designed method, we can get very high strength material that is called composites. So filament winding is one of the technique of manufacturing of composite material, among others. So there are casting methods, there are also many methods. So one of the best method is using filament winding for the casings, which gives some 45-degree angle filament winding, gives better casing material. So in most technology recently, because of its lightweight, composites are intended for lightweight structural application with improved performance. So these are materials for high strength application. So that is motor case. We have to select proper material for motor case. So in motor case, the front and aft booms are wounded internal parts of the case. Suitable openings and fissures introduced to permit removal of the motor case. So this is just so this is a general solid propellant. Again, when we come to solid propellant, which consists of two things, fuel and oxidizer, which are bound in suspension that can produce thrust and through the chemical reaction. Okay, so fuel now oxidizer ሁለቱም ስላለበት easily በማንኛውም አየር በሌለበት ቦታ ባርን ማድረግ እንችላለን ማለት ነው። Another, when propellants are ignited, they release both fuel and oxidizer, consists with which burn and generate the required thrust. So our intention is to get thrust. Okay, so that is the aim. The system generates a lot of thrust that can be stored for long period and ready to go state, but it lacks controllability. What I have said for solid propellant, once it burns, it will not terminate, so that control mechanism is difficult in this case. Material for solid propellant, ammonium perchlorate is considered as oxidizer, and the powder aluminum is considered as fuel. And then we need some extra materials like binding agents, flame retardants. Some materials also required. Okay, so the basic material, fuel and oxidizers are ammonium perchlorate and powder aluminum. And powder aluminum. Again, some hydroxyl terminated polybutadiene like HTBB are used as fuel. And some binding agents also, curing agents are also required. In the case of high performance application, we need energetic oxidizer like cyclotetramethylene tetranitramine. We call it as HMX. And we need energetic fuel like these fuels are sometimes used as plasticizers or binders together. Even binders and plasticizers are considered fuel. They will burn together. So anyways, so these energetic fuels are like nitrocellulose, nitroglycerin. That is called the double-base propellant. So you can see what are the TNT, what are the RDX, what are HMX formulation in your chemistry. This is their chemical structure. Anyways, this RDX is, we call it as research and development explosive. HMX people usually call it as His Majesty explosive. So these are the most common. So propellant mixtures containing nitrocellulose and nitroglycerin. Okay, in most cases, propellants nitrocellulose and nitroglycerin, which have a detonative velocity of 7,700 millimeter per second or 7.7 meter per second. So these are some common shapes of propellants. So in solid propellant, these are some common shapes, but these are not the only one. Okay, and their performance can be expressed in terms of thrust versus time graph. You see, this is thrust versus time graph. Will in most you are expected to design this thrust versus time graph in your next time when we learn about the burning rate and other parameters. Okay, so these are various grain types, grain profiles. Okay, this shows various grain profiles with their performance curve. Okay, this is performance curve. This type of propellant grain gives us initially smooth rising of thrust, and there is random rise of thrust will come, and the failure also like that. So this is the thrust curve for inner cylindrical. And when we come to here, inner there is a star shape of propellant there, star shape. And the thrust time curve shows plateau at the top. Simple plateau, that is neutral. There is no rise on or lower of the thrust. It is almost constant thrust. So it is called neutral. And this type of burning is called progressive. This shows progressive. This one is neutral. Also here, this is neutral. Okay. And this is a regressive burning. This is the word which I lost, where there is burning from outside to inside, from out to in burning. That means a regressive burning. During that time, we can see this type of thrust time curve. Okay, so a thrust time curve ስለሚጠቅማችሁ ወደፊት የምናወራው ስለሆነ identify ያደረጋችሁ እንድትሄዱ ስለፈለኩ ነው። So this is solid propellant grain configuration. What are the requirements? So please go through this slide. It is clearly written in for your information. So just go through the slide and read it. Let me go to the nozzle. So nozzle is one of very fundamental component of the rocket. It is having shape of diverging converging section. There is converging section here. It is converging section here. And there is narrow section, very narrow section around here. And then diverging section. So the flow pattern in every section is different. At diverging section, there is subsonic flow. Subsonic flow related with the flow velocity means the Mach number of the speed of an object is less than 1. Mach less than 1, m less than 1. And when we come to narrow section, it is called throat. So on throat, the flow is sonic flow. Sonic flow means the object speed divided by air speed, means the speed of air in air gives us 1. That means that is called sonic flow. And then it goes to supersonic flow, which is Mach greater than 1. Supersonic means Mach greater than 1. So this is the condition of the flow in the nozzle. So nozzle design is one of important part. So we must consider all the geometric profile and generation of the nozzle shape. So what happened? The combustion product, which is produced at the combustion chamber, like pressure, temperature, area, which are accelerated to and comes through the nozzle. So in the nozzle, high pressure will develop and comes out to this section. So this is our atmosphere, just atmosphere. This is exit, okay, nozzle exit numbered with 2, nozzle throat number with simply T, and the combustion chamber region numbered 1. So this is a nozzle construction. So the principal requirement of nozzle common to both solid and liquid. It is just to able to produce supersonic flow of the exhaust gas from the combustion chamber pressure to exterior pressure as a function that is accomplished by proper countering and proper countering and the sizing. Contour means the shape, the profile. We have to give proper profile. We have to give proper size or dimension. The contour is initially convergent. Yeah, it is convergent here.